In this module, we will discuss the fuel system. We will begin with fuel system description, followed by fuel management and non-normal indications. The fuel jettison system is discussed in Part 2.
There are 4 main fuel tanks, numbered 1, 2, 3, and 4. Main tank number 2 and 3 each hold approximately 38,100 kilograms. Main tanks number 1 and 4 each hold approximately 13,300 kilograms. The center wing tank holds approximately 52,100 kilograms.
2 reserve tanks, designated Reserve Number 2 and Reserve Number 3, are located in the outboard section of each wing. Each reserve tank holds approximately 4,000 kilograms. Surge tanks are located in the outer portion of each wing. Let's take a look at how the fuel quantity is sensed and displayed. Sensors in each tank provide data to the fuel quantity processor. The fuel quantity processor calculates the fuel quantity in each tank and supplies values to the quantity indicators. Pressing the fuel switch on the Display Select panel displays the fuel quantity in each tank. Total fuel quantity is displayed on ICAS and the fuel quantity display. If the fuel quantity display is not available, the fuel quantity in each tank is displayed on the compacted fuel quantity display.
Totalizer fuel and calculated fuel are displayed on progress page number 2 of the FMS CDU. The totalizer fuel quantity is the sum of all the fuel sensors on the airplane. The totalizer fuel quantity will not display if the fuel quantity indicating system is inoperative, a manual fuel entry is made on the performance initialization page, or the calculated fuel use prompt at the 5R key is selected. The calculated fuel is the initial totalizer fuel minus the fuel consumed at engine start. Calculated fuel quantity is not displayed if the fuel flow sensors are inoperative or when the totalizer fuel use prompt at the 5L key is selected. The FMS normally uses the calculated or calc value for performance computations.
Fuel temperature is measured in main tank number 1 and displayed on ICAS. The fuel panel is located on the overhead panel. The fuel panel is laid out schematically. Fuel pumps are represented by their respective switches arranged by tank location. Each pump switch has a low-pressure light. Cross-feed valves are represented by their respective switches. The fuel manifold is represented by flow lines which depict the flow of fuel from the tanks through the crossfeeds to the engines.
In this module, red will be used to show fuel flow.
Each main tank has a forward and aft AC main pump. Pushing a main fuel forward or aft pump switch on activates that pump. ICAS advisory message, fuel pump, is displayed when a fuel pump output pressure is low. The pressure light also illuminates. Main tanks 2 and 3 each have forward and aft override jettison pumps. Pushing the pump switches on arms the pumps for operation. When either center wing tank pump senses low pressure, system logic automatically turns on the override jettison pumps in main tanks 2 and 3. Override jettison pump output pressure is greater than main pump pressure. With both the override jettison pumps and main pumps operating, the override jettison pumps will supply fuel to the engines. The ICAS advisory message, fuel override, indicates an override jettison pump output pressure is low. The low pressure light also illuminates.
With fuel in the main tanks equal and the main tank override jettison switch is off, the override pump messages and lights are inhibited. With fuel in main tank 2 greater than main tank 1 and main tank 3 greater than main tank 4 and the main tank override jettison switch is off, the ICAS message fuel override is displayed. The low pressure lights do not illuminate.
Question. Answer A is correct.
The center wing tank has left and right override jettison pumps. Pushing the pump switches on turns the pumps on.
Center wing tank override jettison pump pressure is greater than main pump pressure. With both the center wing tank override jettison pumps and main tank pumps operating, the center wing tank override jettison pumps will supply fuel to the engines. The ICAS advisory message, fuel override center, indicates a center wing tank pump output pressure is low. The low pressure light also illuminates. With no fuel in the center wing tank and the override jettison pumps off, the message and light are inhibited. With fuel in the center wing tank and the override jettison pumps off, the message is displayed. The low pressure lights do not illuminate. Now, let's look at how to cross-feed fuel. Let's first discuss cross-feed switches 1 and 4. With the switch in the on position, the valve is open. With the switch in the off position, the valve is closed. The ICAS advisory message, fuel cross-feed 1 or 4, is displayed when the switch position and valve position disagree. The valve light also illuminates.
When a cross-feed valve is in transit, the valve light illuminates, but the ICAS message is inhibited. Now, let's look at cross-feed valves 2 and 3. Lifting the guarded cover and pushing the switches on opens the valves and arms them for automatic operation. The fuel system management cards close cross-feed valves 2 and 3 when the flaps are extended to takeoff position. The center wing tank now supplies fuel to engines 1 and 4. Main tank 2 supplies fuel to engine 2, and main tank 3 supplies fuel to engine 3. After takeoff, when the flaps are retracted, cross-feed valves 2 and 3 open. The center wing tank now supplies fuel to all engines.
The ICAS advisory message, fuel cross-feed 2 and 3, is displayed when the valve position disagrees with the commanded position. The valve light also illuminates. When the valve is in transit, the valve light illuminates, but the ICAS message is inhibited.
Reserve fuel transfers automatically. Each reserve tank has 2 reserve transfer valves that feed a single fuel transfer line. When main tank 2 or 3 quantity reaches approximately 18,100 kilograms, system logic automatically opens the valves in both reserve tanks and allows fuel to flow from the reserve tanks to the inboard main tanks. The ICAS advisory message, Fuel Reserve Transfer, is displayed when both reserve transfer valves are not in the commanded position.
The fuel transfer main 1 and 4 switch is located on the overhead panel. Pushing the guarded fuel transfer main 1 and 4 switch on opens the fuel transfer valves, allowing fuel to gravity flow from the outboard main tanks to the inboard main tanks. Further discussion of fuel transfer will be covered in non-normal indications.
Question. Answer C is correct.
Now, let's look at fuel management. We will take a normal flight from the time the flight deck is entered to engine shutdown at our destination. In this example, we start with all tanks full.
With AC power established, the number 2 aft main tank fuel pump supplies fuel to the APU. If the number 2 aft main tank fuel pump switches off, APU system logic automatically turns the pump on when the APU selector is rotated out of the off position. The Atlas 400 freighter fuel system is configured to supply fuel to the APU utilizing both number 2 aft main tank fuel pump and the number 3 aft main tank fuel pump. This prevents severe fuel imbalance if loading delays are encountered. System logic is the same, but with number 3 aft main tank pump incorporated in the logic circuit.
Before engine start, all fuel pump and crossfeed valve switches should be on.
After engine start, the center wing tank feeds all engines.
When flaps are lowered for takeoff, system logic automatically closes crossfeed valves 2 and 3. The center wing tank now feeds engines 1 and 4. Main tank number 2 feeds engine number 2. And main tank number 3 feeds engine number 3. After takeoff, when the flaps are up, system logic automatically opens crossfeed valves 2 and 3. The center wing tank now feeds fuel to all engines.
The ICAS advisory message, Fuel Override Center, is displayed when the center wing tank is empty. Pushing the center wing tank pumps off removes the ICAS message. When the center wing tank is empty, system logic turns on the override jettison pumps in main tanks 2 and 3. When either main tank 2 or 3 reaches approximately 18,100 kilograms, system logic transfers reserve fuel to the inboard main tanks.
The ICAS advisory message, Fuel Tank to Engine, is displayed when the fuel quantity in main tank 2 is less than or equal to main tank 1, or main tank 3 quantity is less than or equal to main tank 4.
To configure the control panel for tank to engine operation, first, push the main override jettison forward and aft pump switches off. Then, closing 1 and 4 cross-feed valves configures the fuel system for tank to engine operation and removes the ICAS message.
After engine shutdown, all fuel pump switches are turned off.
Question. Answer A is correct.
Now let's discuss non-normal indications. The ICAS caution message, Fuel Pressure Engine, is displayed when the cross-feed valve is closed and both main pumps have low pressure.
The ICAS advisory message, Fuel Imbalance, is displayed when tanks 2 and 3 have a fuel difference of 2,700 kilograms, or when main tanks 1 and 4 have a fuel difference of 1,300 kilograms, or after the tank-to-engine configuration is established and the total of the inboard main tanks differs from the total of the outboard main tanks by more than 2,700 kilograms.
The ICAS advisory message, Crossfeed Configuration, is displayed if crossfeed 1 or 4 valves are closed and the main tanks are not equal, or if crossfeed valves 2 or 3 are closed and the flaps are retracted. The ICAS caution message, Fuel Quantity Low, is displayed when there is less than 900 kilograms of fuel in any main tank. The ICAS advisory message, Fuel Temperature Low, is displayed when the fuel temperature is below minus 37 degrees centigrade. The fuel temperature display in ICAS changes to amber.
Fuel temperature in flight must be maintained at least 3 degrees above the freeze point of the fuel minimum operating temperature. Fuel type freeze points are Jet A minus 40 degrees Celsius, JP5 minus 46 degrees Celsius, Jet A1 minus 47 degrees Celsius, Jet B minus 50 degrees Celsius, JP4 minus 58 degrees Celsius. This information is found in your Flight Handbook 15.20.15 or the Boeing Flight Crew Training Manual 3.6. Maintaining a minimum fuel temperature should not be a concern unless the fuel temperature lowers to within a few degrees of limit. You may consider trying to raise the fuel temperature in one of 4 ways: descend to a warmer air mass, divert to a warmer air mass, or increase Mach number. An increase of 0.01 Mach will result in an increase of 0.5 to 0.7 degrees Celsius total air temperature. If the turbofans is low, consider climbing to a warmer air mass, as in over-the-pole flights. The ICAS advisory message, Fuel Temperature System, is displayed if the fuel temperature sensing is inoperative. However, a procedure found in the QRH, or Quick Reference Handbook, will advise the flight crew to use the total air temperature displayed in the upper left of the primary ICAS as an indication of fuel temperatures. The ICAS advisory message, Fuel Transfer 1 and 4, is displayed when the fuel transfer switch is pushed on before main tanks are equal, or while the aircraft is on the ground.
In Part 2, we will discuss the fuel jettison system. The fuel jettison control panel is located on the overhead panel. A placard on the panel advises of a limitation against fuel jettison when flaps are in transit between positions 1 and 5 to alleviate the possibility of fuel contacting the aircraft because of changing airflow as the outboard leading edge flaps move. There are two jettison control systems, A and B. Jettison Control System A or B automatically controls jettison. The jettison control system positions valves and controls pumps to maintain fuel balance and to stop jettison. Rotating the fuel jettison control selector to A or B selects the respective jettison control system. When a jettison control system is selected, a preset fuel to remain quantity is displayed on primary ICAS, and jettison times is displayed on the secondary ICAS fuel synoptic.
Rotating the fuel to remain selector changes the fuel to remain quantity. A quick method to determine the amount of fuel to remain is to subtract your zero fuel weight from 302,100 kilograms, which is your maximum landing weight. Pushing the left or right guarded nozzle switch opens the respective jettison nozzle valve. Pushing one or both switches also allows the jettison control system, through the fuel system management computer, to position the fuel jettison valves and operate the override jettison pumps, which begins fuel jettison. Jettison time is initially estimated using pre-programmed rates. 90 seconds after jettison starts, the time to jettison updates based on actual fuel quantity, rate of change. The jettison control system maintains fuel balance and terminates jettison by controlling the center wing override jettison pumps, the main 2 override jettison pumps, and the main 3 override jettison pumps.
The jettison control system appropriately positions the jettison valves and the main 1 and 4 transfer valves throughout the fuel jettison process. The fuel system management computer will transfer reserve tank fuel normally if required.
Fuel continues to jettison until the fuel to remain quantity is reached.
The fuel to remain quantity is displayed as magenta until total fuel quantity equals the fuel to remain quantity. When both quantities are equal, the fuel to remain display turns white and flashes for 5 seconds. When total fuel quantity equals fuel to remain, all override jettison pumps are disabled by the fuel jettison system, and jettison stops. The respective ICAS advisory fuel override messages are displayed until the fuel jettison selector is off.
Pushing the guarded jettison nozzle switches off closes the jettison nozzle valves. Rotating the fuel jettison control selector off unpowers the jettison control system and removes the fuel to remain display. Fuel jettison can be terminated at any time by rotating the fuel jettison control selector off and by pushing the fuel jettison nozzle switches off. Now, let's discuss jettison system non-normal operations. The ICAS advisory message, Fuel Jettison, is displayed when the selected jettison control system has failed.
Rotating the fuel jettison control selector activates the other control system. The ICAS caution message, Fuel Jettison System, is displayed when total fuel is less than fuel to remain, or if the second jettison controller fails. Jettison should be terminated. Should jettison fail to terminate, standpipes prevent fuel from jettisoning below 3,200 kilograms in each main tank. The ICAS advisory message, Jettison Nozzle On, left or right, is displayed when the jettison nozzle switch is on and the nozzle valve is open. When both jettison nozzle valves are open, the ICAS advisory message, Jettison Nozzle On, replaces the individual nozzle messages.
The ICAS advisory message, Jettison Nozzle, is displayed when a fuel jettison nozzle valve and switch position disagree. The valve light also illuminates.